Hello everyone. Today let's discuss certain improper fractions where the numerator is in fact a multiple of the denominator. So for instance, consider the improper fraction 24 over 6. Notice this is an improper fraction since the numerator is greater than the denominator. Also notice this is a very special case of a special example of an improper fraction. I specifically chose one such that the numerator is actually a multiple of the denominator. And let's see what happens. Now from a previous lesson, you do know that 24 over 6 may be written in this manner. 24 is 4 times 6. And then using the cancellation law of fractions, we can cancel the 6's and get a 4. That means what we are saying is that this improper fraction 24 over 6 is exactly same as the whole number 4. Now there's also another way that you can think about this. You can look at 24 over 6 and you can think of it as 24 copies of the unit fraction 1/6. And also early on we made an observation that 6 copies of 1/6 make up a 1. So you have 24 copies of this and every 6 copies make up a 1. So we can ask ourselves how many ones are hiding in these 24 copies of 1/6, where every 6 copies make up a 1. So that's really asking how many 6's are there in 24. So let's count in 6. 6, 6, 12, 18, 24. So that's 4. And that is in fact this 4. So what we are realizing is when the numerator is a multiple of the denominator, such as this situation, 24 over 6 seems to really match with 24 divided by 6. Why is that? From the explanation I just gave, where we said we need to know how many 6's are in 24. That is what we call measurement interpretation of division. That's really calculating 24 divided by 6. So in the very special case, when the numerator is a multiple of the denominator, then such as this, 24 over 6 really matches with 24 divided by 6. So let's look at it on the number line. So here's your 24 over 6 that matches with 4. 6 of those 6 1/6 are in here, another 6 1/6 are in here, another 1/6 and another 6 and another 6. That's how you'll get your 24 over 6. In other words, if you were to cut up the unit segment into 6 equal pieces, the point or the number at the first tick mark would be 1 over 6, and then you count 2 over 6, 3 over 6 and so on. When you say 6 over 6, you're exactly at 1. Then 12 over 6, you're exactly at 2. 18 over 6, you would be exactly at 3. 24 over 6, you would be exactly at 4. Now let's look at some problems. Okay, let's read the problem. In each of the improper fractions below, the numerator is a multiple of the denominator. So I actually picked very specific improper fractions. I picked them in such a way, I wrote them in such a way, you'll notice the numerator is actually a multiple of the denominator in each case. And now I'm saying write each improper fraction as a whole number. So in these special cases, each of these improper fraction will be a whole number by our discussion. There are many ways you can do it. You can either use a previous lesson cancellation law, and you can write out, I'll do this in 2 ways. 30 as 3 times 10 over 3. Cancel out the common factor of 3 and get an answer of 10. Or by what we just discussed, we can think really 30 over 3 can be interpreted as 30 divided by 3 in this special case, because 30 over 3 is 30 copies of 1/3. Every 3 copies make up a 1. So we ask ourselves how many 3's are in 30. That is 30 divided by 3, and we get a 10. Okay, and these I will use the division interpretation and obtain it. So 45 over 9, so let's count in nines. 9, 18, 27, 36, 45. So that's 5. And 56 over 7, let's count in 7. And in fact, to repeat the argument, 56 over 7 is 56 copies of 1/7. And 7 copies of 1/7 make up a 1. So we're asking how many 7s are in 56. So let's count in 7s. 7, 14, 21, 28, 35, 42, 49, 56. So that's 8. So that's how we can convert improper fractions, this special type of improper fractions, into whole numbers. These improper fractions were chosen so that the numerator is in fact a multiple of the denominator.